Welcome to the finale of Security Explained. Over the past 4 episodes, we've built up the theory, threat models, attack surfaces, the layers that make up a modern system. Now it's time to put all of that into practice. In this episode, we're going to harden a real system, layer by layer, and shrink the attack surface down to only what we actually need. So let's start with the problem itself. Software almost always ships configured for convenience, not safety. Every feature switched on, every port listening, default accounts in place, errors leaking detail. Out of the box, you inherit a huge attack surface you never actually chose. Hardening is the deliberate process of reversing that, systematically removing, restricting, and locking down everything you don't need until only the necessary remains. If we boil it down to a single sentence, hardening is the process of shrinking a system's attack surface, so there's simply less for an attacker to reach. 3 ideas worth holding on to here. A smaller surface means fewer ways in. It's a continuous process rather than a one-time fix, and it has to be applied in layers across the OS, the network, the application, and the data itself. Picture a default system as a building with 8 doors wide open, every service running, every port listening, every feature enabled just in case. A hardened system is the same building with 1 door, locked, monitored, and only opened for traffic that genuinely needs to pass through. That's really the whole game. Hardening is mostly subtraction. Every door you close is one an attacker simply can't walk through. Now, before we open any specific checklist, it helps to know that almost every hardening guide you'll ever read boils down to 4 principles. Least privilege. Give every user and process only what it actually needs. Reduce attack surface. If it's unused, turn it off. Uninstall it. Close it. Defense in depth. Stack your layers so a single failure isn't catastrophic. And secure defaults. Start locked down, then open things deliberately, only when there's a reason. Learn these 4, and the rest is just applying them to a specific target. And applying them means thinking in layers. At the network edge, you've got firewalls, closed ports, segmentation, admin access locked behind a VPN. One step in, the host and OS itself, patched, stripped of unused services, with users that only have the privileges they truly need. Then the application, validating input, configured securely, with default credentials and sample pages long gone. And finally, the data, encrypted at rest and in transit, with secrets properly managed. The point is, there's the stack. An attacker has to defeat all 4, and a gap in one layer is quietly covered by the next. Let's make that concrete on the service every server exposes, SSH. Out of the box, it accepts root logins and password attempts from anywhere on port 22, a noisy target for automated scanners. With just 6 lines in SSD config, we close that down. No root logins, no passwords at all, keys only, an explicit allow list of users, a non-default port, and a hard cap on guessing attempts. Same daemon, dramatically smaller attack surface, least privilege, applied with a text editor. That SSH example is just one target. The same thinking scales across every layer you run. On the OS itself, hardening means patches, trimmed services, careful user accounts, and tight file permissions. In containers and Kubernetes, it's non-root workloads, minimal images, and policies that enforce them. For databases, least privilege, encryption at rest and in transit, and never shipping with defaults. 4 principles, 4 targets. Each one a discipline of its own. Now, the good news is you don't have to figure all of this out alone. The industry has already done the heavy lifting. CIS benchmarks give you consensus-driven hardened configurations, and DISA STIGs offer government-grade hardening guides for almost every OS, database, and platform you'll touch. Start from one of these, adapt it to your environment, then codify it in Ansible or your IAC tool of choice. So every new machine you spin up is born hardened, not retrofitted later. But even a perfectly hardened machine doesn't stay hardened, which brings us to the mindset shift that ties this whole series together. Hardening is a loop. You assess what's exposed. You apply your benchmark to lock it down. You monitor for drift and new attacks. And then you repeat, because next month brings new CVEs, new services, and configuration changes that quietly chip away at yesterday's work. A system you hardened last year isn't hardened today. And that loop only works if you can actually see what's happening on the system. Hardening shrinks the attack surface, but it never gets it to zero. So the final layer is visibility. You want security events logged, configuration drift detected the moment it appears, and alerts firing when something looks off. That's the bridge into observability. If a breach does slip through, the difference between a minor incident and a major one is simply how fast you noticed. Before we move on, let's clear up a few myths that quietly sabotage hardening efforts. The first is that you harden once and you're done, but systems drift. New CVEs land every week and configs change. So this is a cycle, not a checkbox. The second is that hardening means piling on security tools, when in reality, it's mostly the opposite. You're removing and disabling, subtracting attack surface rather than adding software. And the third, that it'll break everything, usually doesn't survive contact with a proper test and staging process. The real risk is leaving the system untouched. So, with those myths out of the way, here's what doing it well actually looks like in practice. Start from an established baseline like a SYS or STIG benchmark instead of inventing your own. Aggressively disable and uninstall whatever you don't need. And bake hardening into your images and automation so machines are born locked down rather than tightened later. Then keep patching, monitoring, and rehardening on a cadence. On the avoid side, shipping defaults, treating it as one and done, experimenting blindly in production, and reaching for more tools when the real win is less surface. And the good news is you don't have to do any of this by hand. For benchmark scanning, CS, CAT, and OpenSCAP measure your system against established standards, while Linus gives you a focused Linux audit with concrete recommendations. Ansible and other infrastructure as code tools let you encode those hardened configurations once and apply them everywhere. Then fail to ban blunts, brute force attempts, UFW or neftables give you a host-level firewall, and Trivy and Kubebench extend the same discipline into containers and Kubernetes. So if you take nothing else away, hold on to this. Hardening is really just shrinking the attack surface, guided by least privilege, secure defaults, and defense in depth. You apply that thinking at every layer, on network, operating system, application, and data. And you don't start from scratch. You start from CS or STIG benchmarks and automate the work. And remember, this isn't a one-time project. It's a cycle. Assess, harden, monitor, then come back and do it again. And with that, the security series comes full circle. We started with OWASP Top 10, the map of what can go wrong. Then we went deep on the big attack classes, injection, authentication, and crypto. And today, we closed the loop with hardening, systematically locking it all down. Know the risks, understand the attacks, then remove the surface. That's security, end to end. So if you're sitting down at a fresh box tonight, here's your first pass. 4 moves that do most of the work. Patch everything to close the holes that are already public. Strip out services and accounts you don't use, so there's simply less to attack. Lock down SSH and the firewall to control who can even knock on the door. Then apply a benchmark like CIS and keep an eye on it. Honestly, just these 4 put you ahead of most systems on the internet. And if that first pass leaves you wanting more, this is where you go next. On the left, the rest of the Security Explained series digs into the application side. OWASP, injection, authentication, secrets. The attacks that hit your code, not just your OS. On the right, the Dargslan hardening courses take you deeper into specific systems, SSH, Kubernetes, Postgres, and the newer frontier of AI and LLM security. Pick whichever matches the surface you're defending. Before we wrap, I want to turn this around. Everyone who's hardened a few systems has a ritual. That first move you make the moment you SSH into a fresh box. Maybe it's killing root login, maybe it's locking down the firewall. Maybe it's just running updates before anything else touches the network. I'm genuinely curious what yours is, so drop it in the comments. And that brings Security Explained to a close. 5 episodes covering the risks, the attacks, and the hardening mindset that ties it all together. If you're ready to move from theory into real practice, the hands-on courses over at dargslan.com are where this goes next. Subscribe so you don't miss what's coming, and thanks for spending this time with me.